All right. So we're going to double check velocity. You can see we have the skateboarder evolution topic, and then we're going to generalize it to kind of a general motion of the type that that Logan exemplified. And then we're going to talk about something called a distance polygon towards the end of lecture, hopefully if we get that far. But before we do that, I have a couple things I want to review with you. The homework number 1 mix-up was based on this diagram, and you guys did a good job interpreting the diagram. We're actually going to talk more about this diagram a little bit later. So one item in the matching was better given after today's lecture than after Thursday's lecture. So what we'll do is if you have a score in both of them, we'll reconcile those scores together. And if you only did the new version, then that'll be your regular score. Okay, and I'll post one replacement for both of those. Okay, so it'll look a little bit bodacious, but hopefully it'll be comprehensive. I'll tell you more about that on Thursday. I couldn't do it until you guys finished the assignment. But we'll do it we'll talk about that on Thursday. Okay, another thing. A student asked me, Dr. B, how come Canvas web courses always puts those extra zeros in there? You know, like if I type in 0.33, it automatically adds a bunch of zeros. And yes, that is correct. It does. I have no idea why it does that. There's probably some guy, at the Canvas instructor company that insists on it. But if 0.33 is correct, those zeros are not going to make it incorrect. So just ignore them. I mean, I think I kind of know why they're putting extra zeros in, because they want to have everything with 4 decimal points or 5. I don't know how many they put on there. Forget. But at any rate, don't worry about those zeros. Now, if 0.33 is the correct answer, then the zeros are not going to interfere with that. It'll be marked correct, and you'll get plus 1 point or whatever the score is. But if it's not correct, I mean, web courses will also know that. So, you have to be thinking you have to do the correct calculation, but those extra zeros are not going to interfere with anything. So type in what you think is correct and then go by the results. Another thing, a student sent me, I don't know if the student is in this section or not. Their name's not on here. Last night I got a message. Good evening, Dr. B. I have attempted the homework twice, and I keep getting the same 2 questions wrong. Is there a possibility you could help explain to me what I am doing wrong? For number 2, I have tried, and then, the rest of the message. Now, what I told that student, I'll tell to everyone in here, because I want everybody in here to take this practice. If you have a question like this, messaging me about it, you're not doing something wrong, but I'm going to ask you to post it as a new thread. Instead of sending me a message, put it in a discussion thread. Although what you really want to do is first check the other threads and discussions. Okay? And that way, it's when I say that, post this in a new discussion thread, please. I'm not saying your answer's bad or anything like that, but what I am saying is that I will try to answer you there, and chances are a student, one of your classmates might type in a tip for you before I get to it. All right? But then if it's in discussions, all your other classmates, all 400 of yous, will be able to see what I type in and what your classmates type in. And that is generally more helpful. So it makes the discussions into like a virtual study group. Now you have to identify your thread. Don't just put I need help. Type in, well, how do I tackle number 2 on homework 1 or number 7 on homework 5, when we get to homework 5. Okay, so do that, and the threads will be helpful. Now, there was a thread last night that Tiffany, Nguyen, and I both, she got to it before I did. Sebastian, are you in here? Sebastian started it, and then Tiffany, are you in here? Yeah. So Tiffany answered it. She did. She. I think that was question 2 that she gave a tip about, and then I typed in a couple things about question 3. The strobe photos and everything like that. All right. So that works out good, and we'll try to do that. And I noticed. Sebastian's, unfortunately, something happened to his, did you notice that? His initial message disappeared for some reason. But hopefully your messages will not disappear the way Sebastian's did. And we'll get questions in there to help you and coach you along. Now, Tiffany did not type in the answer for Sebastian, nor did I. So if you feel like, yeah, I know how to answer this, go ahead and give your classmate tips and kind of coach them along to the right answer. And then if they say, oh, yeah, I got it right now, then you can say, okay, great, But don't give the answers. And the reason is, a lot of times, you don't know the answers that they're going to go for. For instance, with calculations, and this is in general, not just the homework 1, when you have a calculation question where you type in the number, like 2.52 for your answer, and then you hit the submit key. Those questions, the way that Canvas works, they always generate at least one new random value for one of the measurements in the problem. So if it's, calculating a velocity with some, or a speed with some delta x and some delta t, Canvas, like for instance, the Icelandic jet problem, the same time interval, 30 minutes, but it was set up so that Canvas gives different distances that the swimmer moves. Okay, and so different speeds. So telling somebody, well, the answer is 0.25 meters per second is nice for your problem, but it might not be for the students. So giving tips and not answers specifically is better off for that reason too. All right, questions about discussions? Okay, let's keep going. Textbook website. It's almost ready, and you can actually purchase it now. I'll give you the website address here in case you didn't have it. Has anybody already done that with their card? Have you been into the website? Yeah, so you can read the book and right. Do they have page numbers, or is it? Because I haven't seen it yet. Yeah, okay. So you can actually get in there. I'm going to show you a couple pages about that. So reading should be possible. Now there's going to be mini review sets, and those are going to be our homework, okay, in the textbook website. So we're going to be doing 2 parallel homework venues. We're going to be doing some homework in web courses, which we've already started, and then we're going to have mini reviews chapter by chapter in the textbook website. So those will be assigned. Now, when you register up, you have to use your NID. Did you do that? Use your NID? Yeah, so you want to use your NID. And for those of you that are newbie freshmen, the NID and the PID are different. And I'm doing you a public service to say that and emphasize that, because my first semester here as a faculty, I didn't twig to the fact that they were different until like Thanksgiving. So I was doing a lot of flailing in the internet, all the UCF websites and stuff, because I didn't realize that they were two different numbers, and I was trying out different. Anyways, so keep them separate. You're going to need your PID on your Scantrons on exams when you fill those out, but NID everywhere else, and NID here. All right, so that's 2 letters followed by a few numbers. Question in the back.
Will we get notifications on the courses
Yeah, you'll get. The question was, will we get notifications on web courses about homework on this site? And the answer to that is yes. You'll be seeing me for 3 hours a week, so I'll be nagging you about it. So I'm going to be like your mother-in-law for the next 90 days. And you'll get them in web courses, like announcements and maybe discussions. And then when you log into the site to read, there'll be a little alert, that the mini review is ready and stuff. So you'll see there'll be, several channels by which I'll transmit, an alert. So classroom, web courses, and the site itself. Question up here, Colin. Wait a minute now. Wait a minute, hold on. What is your name again? Axel. Okay, Axel. It is not a physical textbook. And you guys, if you buy a physical textbook, that you've bought something that somebody's pirated, okay? They're getting money off you for something that cost them zip zap. It's never been published in hardcover or softcover. It's always been an ebook. Now it's on a website. So I haven't even gone into the website. What did you think of it? Does it seem pretty?
It's kind of just very small and compact. I just looked at it and you see no notification numbers, but it's in the chapters.
Okay. All right. So we're all going to be getting used to this new website. I had some training yesterday with the textbook publisher about the back end, where I administer everything, set dates and stuff like that, and alerts and whatnot. By the way, the other thing that I want you to do when you register for this is use your NID and your Knight's Mail email address. And that's actually going to be your username, I believe. And I think they set it up to be your password when you sign up. Is that what you got? Did you get that?
They sent me an access code so I can get it.
Oh, you had the access code. Okay, so now let's get to that. I have a couple other things I want to go through with you. Our homework for now is until those mini reviews. We're not ready for one of the mini reviews anyways. But when those are activated, hopefully this week they thought those would be activated. I'll consider setting them up. Okay, Axel? So, but I'll let you guys know. And either way, if it's in the textbook website or web courses, always focus on lecture, because lecture is like the prime directive. All right? Everything that I consider important is in lecture. And everything is derivative of that. So whether it's a homework assignment in web courses or a homework assignment in the ebook website, your main resource is the YouTube, the lectures that are recorded and placed onto YouTube. So focus on those. Khalid.
Will we be using the textbook during lectures at all?
The question is, will we be using the textbook during lectures? In a way, because as you read the textbook, you'll hear me lecturing. Because the language I wrote, my TA last year said, Dr. B, when I read your book, I can hear you in lecture. But you don't have to. I mean, it's an ebook, so if you have if you have your laptop or whatever, it's available to you. So, but we're never going to go, okay, go to page 7 or anything like that. All right, so keep an eye on the YouTubes. Now, here's the website. Go ahead and jot this down. heyereducation.kendallhunt.com/interactions. And price is $90. You guys, I'm not sure how much longer I'm going to stick with these guys, because when I wrote the book, I was hoping, I said, let's make it an ebook, hoping that the price would be less. But this is still a huge, and I don't hardly get any. This my money goes to these guys out in Iowa, out in Dubuque way, and I get a royalty, and I pay my royalties at the UCF. So, anyways, I was hoping for something like about $20, but and the bookstore is even worse. So, but you can go here and purchase it. You get an access code, and it grants you access to their Great River website. And this is like content management system, kind of like Canvas, but it's not Canvas. It's Great River. So use your NID and your Knight's Mail email address when you register, and that'll be helpful. Now, the other way that you can get it is by going directly to the Great River website, GRTEP. I don't know what TEP stands for, but Great River something, educational products maybe. Anyways, you'll see a picture like this when you first log in. And if you've bought the access code, you're good. I mean, they got it right up here. All right, so there's the access code. And so if you have that, you just type it in here, then you just register and all that stuff. But you can actually purchase it. If you go to that website, grtep.com, you can purchase there, if you haven't already purchased. And so for those of you that do not want to go over to the disaster bookstore, you can just click over here. All right. And then after you join, you're always going to come to this, this is going to be your sign-in page. It's going to look just like this. So you type in your username and your password and change your password. Oh, by the way, I did that this morning. I joined up the website this morning before school, and I could not find in my account settings, I could not see where it allowed me to type in a new password. Because usually, when I join a website, I immediately change the password. And I couldn't. So what I did was I signed out, and then I did forgot password, and they'll send you a reset link to your Knight's Mail email address, and then you just do the reset link and stuff like that. And they'll ask you when you join up and you set up your account and stuff. They'll ask you for a password challenge question. What was your favorite pet's name, or something like that, and you set that in yourself, and then you do the password reset, so you can get your reset code and type in your patented top secret password, Sharknado, or whatever your password is. All right, so here's the close up. So first time users, you're going to be going over here. So that's good. Now, questions about that before we continue? Yes. A link? You mean on the internets? Yes. I just got it this morning. I'll put it in web courses, but I just typed, it's on the screen. It was on the screen a minute ago. You didn't type it in? Okay. Oh, yeah, okay. You know, I used Safari for this Great River TEP.com, grtep.com. And Safari seems to be okay, but we're probably going to get some experience as a group. For Safari, you got to watch out for this. For Google Chrome, you got to watch out for that and stuff like that. But I seem to be clicking okay on that. All right, prepare your iClicker for clicking. We're going to do some clicking, my wonderful students. And let's get this class going. We're going to use the iClicker system today. We're going to we got one goofy question for practice. And all these are practice questions. These are not official till a week from today. But anyways, if it's the first time you have, by the way, I notice that a lot of you are registered now. But if you haven't registered, get registered right after class if you can. Because I won't synchronize, you won't get a bonus point unless you click and you're registered. And I'll synchronize the roster this afternoon so you can, it'll be, maybe 1 o'clock when I go and do that. So between class and 1 o'clock or so, you can still get a bonus point for today. Okay, so hold the power button until that should be upper left rectangle. The upper left rectangle flashes. And then type in the frequency DD, and you'll get the Go Nitro message, and then you'll see the ready, and then you'll be ready. And what we're going to be doing here is numeric entry. So here's your calculation. 2 events in space-time, position and a time. Calculate the average speed. And just take a minute. And this is a calculation, so if you want to consult with your neighbor, also break out your calculator, and then that'll be good. So Casey, you have 2 neighbors, 1 on each side, plus a second neighbor out on that side over there. So you can be the brains of the operation over there. All right, so type in your number, something, point something, something, and then hit the send key. Now, we did this last week, and actually I can look. Let's see what you guys are typing in. Yay, I have the right answer. The only person that's typed in so far got it right. So type in your number and then hit the send key, and everything will be righteous. And just so you know, the decimal point, on this one we're using a decimal point, and it is hard to see. Sorry about that. Really hard to see. And I think it's like 2 clicks below the 0, if I'm not mistaken. What was that? What were you doing with her clicker?
She wasn't on correct frequency.
So you held the power button down, and then you... Yeah, and if you have, what is your name back there? No, the young lady behind you. Carson, and what's your name? Tyler. And everybody, if you use it for another class, you may have to change back to AA, if that's what you're. But this is how you do it. So if you're, when you first start up in the morning, if it flashes AA, do what Carson just told you. Because the reason I did that is because okay, getting answers in here. Yeah. The numbers, they're up and down arrow keys. Yeah. And then you hit the right arrow key to put in your next number or a decimal point. So you're going to type in a number and then find the decimal point and then 2 more numbers to the right and then hit the send key. Whoa. I better check this. Okay. Double check your answers. I see a few. Don't just type in 0. Try to get the right answer. Connor, you get it? Okay. Kwame, you got it? Good. What is your name again? That's right, Alondra. Okay. You told me that the other day and I forgot. Just try. Tracy, right? No, what is your name again? Yeah. Katie. Okay. I knew it was an A and an E. Okay, Katie, I'm just trying to get everybody's names here. Okay, 1 minute. And you know, the thing about studying with a neighbor or, you know, kind of kibitzing with a neighbor is you can check, see if they've got the right answer or if you've got the right answer. You know, if you both agree, then it's possible that you're both correct. It's possible you're both incorrect, though. So you got to know your stuff. You can't just dream up numbers. 30 seconds. But it's looking pretty good as far as I can see here. We're doing all right. 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, we got fewer students answering today, only 72. I think we had a little bit more than that last time. Yeah, the answer is 1.02. And raise your hand if you got 1.02. Okay. Ooh, a little nugget of 1.02s over here. Very nice. Yeah, it's basically delta x over delta t. And delta t is pretty easy. 1.4. 4.6 minus 3.2. So the elapsed time is 1.4 seconds. And the distance, 1.43 meters. So 1.43 meters divided by 1.4 seconds is pretty close to 1.02. Let me look at, let me show you that. Let's look at the answers briefly. See if there's any bloopers here that are. So there's the right answer, 1.02. I was looking at these, trying to figure out, okay, here's a couple people, 1.04, probably rounded off incorrectly. 1.2, I don't know, maybe you typed in the decimal point wrong. 3.56, that's one of the coordinates. No, it's not. 4.2, 8.15. Yeah, it's hard to interpret these. But a couple of these, might be.
Can you explain how you got the answer?
Yeah, I did. You subtract. I already did that. You subtract the x coordinates, later minus earlier. So 3.93 minus 2.5. That's your delta x. So that's 1.43 meters. And then your delta t is t final minus t initial. So 4.6 seconds minus 3.2 seconds, that's 1.4. Then you take the quotient. So the numerator is 1.43 meters and the denominator is 1.4. So the answer is pretty close to 1, and if you actually calculate it out and round it off to the nearest hundredth, it's 1.02. Now, what we're going to do now is go to the document cam, and we're going to work out the speed calculations from Evan, Katie, and Logan. Let's see. I'm going to keep recording. So let me see if I can get my cable over here. Dude. All right. Let's do some calculations on the document cam. And what I'm going to do is, when I get back to my office this afternoon, I'm going to scan the paper here, the notebook paper. What is your name again? Selena. Selena gave me some newspaper, some notebook paper, and I'm gonna scan that into PDF and then insert it into this PowerPoint file. So let's keep your clickers ready because we're gonna keep clicking. All right. All right, so Logan's Run. That's the name of a famous movie, I think with robots in it or something like that. Okay, so Logan's Run, the distance was 9.94 meters, right? Is that what?
Yeah.
Okay. All right, now, Katie had 2 times. What were those 2 times?
The first one is 6.48.
6.48 seconds. 6.36 seconds. And Evan?
6.41.
6.41.
And 6.17.
6.17. And hey, you guys, you can see that there's a little bit of, yeah. Let me see if that's not showing up good. Let's see here. Hold on. No, let me turn off these. Oh no, that's in the back. Dude. Oh, I can't turn those lights off. Okay. Hold on a second. Boy, is that bright. Good gravy. I wonder how you calibrate this. I know. I'll just bring it down here. That's better. Okay. All right. So here are my times. And notice, as I was saying, that we've got a little bit of slop in our measurements. Okay, S-L-O-P, slop. That's what a scientist would say. We got a little slop in here. In other words, you got a little plus or minus. They're not perfect agreement. That's normal. That's physics. And we've got a distance here. Now, we only made one measurement of that. So let's draw a little basic layout here. Okay, here's the triangle. So I'll just make a right triangle there. And here's Logan's basic layout. Now, we don't know what the tilt angle is here, but you could probably figure it out. We're not going to do any trig here. We're just going to basically do some calculations of time and so forth. So let's get delta t. Okay, delta t is this stuff divided by 4. So what we're going to do is add these up. Let's see if I can do this without messing up. 8, 14, 15, 22. Carry the 2. 6, 9, 13, 14. 4. Carry the 1. 7, 13, 19, 25. 25.42 divided by 4. So that's 6.3 what? 6.355? Okay, so 6.36. Okay, we'll round that 355 up to 36. Okay. So delta t is 6.36 seconds. Now that's for Katie and Evan. Now you may have a slightly different delta t. And you go ahead with your delta t. And then you can double check against this. And I'll be putting this into the website. And delta x, we did that directly, 9.94 meters. So that's squared away. Now, what we want to do is calculate now, I'm going to move up here, the average speed. All right. And the average speed, the symbol is V with a bar over the top of it. Okay, and I believe I used that notation in the textbook. But it's just delta x over delta t. And I don't know what the answer is here, so let's do it together. Okay, 9.94 meters divide. Oh, I just broke the tip of my pencil. Gosh, but I have a backup. Okay, 9.94 divided by 6. So this is going to be about 1.5 meters per second or so. What does that come out to? 1.56? All right, we have 3 significant figures. So 1.5. Okay, let me verify that. 9 point. See, this is how you guys do it on a test if you forget your rig. 6.36. Okay, 1, 636. 4 times 10 minus 6 is 8. 8 minus 3 is 5. And 3. Okay, so that's a 5, but not a 7. It's not a 6. Okay, so 5, 0, 3, 15, 18. Sweet! 15, so carry the 1. 31. Oh, not so sweet. Well, that's not too bad. 1.5. So 6 you say is better?
No, I got 1.56.
What do you think in the back there? Okay, let me see. Let me try 6 here. 6, carry the 3. 18, 21, carry the 2. 36, 38. Yeah, that's going to be 4, 8, 1, Yeah, okay, so that's going to be a 3. So it's going to a 1.562. So 1.56 meters per second is good. All right, I agree with that. I'll put a smiley face here. So that's good. All right. Now, I want to go back to the regular. I'm going to scan that in and embed it into the video. You'll see it. It works pretty nice. All right, so we just did the average speed calculation. And this caption here, let me move this up here now. This caption is going to be replaced by the actual scan of the scratch work that we just did. But now I have some follow-up questions for you with iClicker. So, as I said, we're not done with iClicker yet. Hit the refresh mode because we're going to do something a little bit different. We're going to type in some letters now. As I promised last week, we're going to do some alphanumeric data. All right, and you're going to be typing in a bunch of letters. Now, this is the first time we've done letters. So hit your refresh key. And let me set up alphanumeric or short answer. Now hit your refresh key now, and you should, does it start with the letter A? Yes. All right, so that means you're keyed in. Now you can still type in numerals, all right? But you're going to type in a sequence of letters, and you could type up to 16. But you're probably not going to need it, because here's your task. And this is a goofy question. This is a practice question, all right? Describe a decision you would make concerning snacking activity. Type in the letters that form your answers. And there's the code table down there, A through Q. All right? So, for instance, type in the letter CBA, meaning sharks consume Cheetos, and then hit the send key. Now, don't do that, because that's my answer. Okay? But you go ahead and type, just so it's just something goofy. We're just trying to type in some letters and then hit the send key. And we're going to do a scientific version, a scientific question of this type in just a second. But for first time out, we're just going to do a goofy. And you know what? We're going to look at some of the answers here to see how much of it. Somebody just typed in the letter E. Sharknadoes. Well, that is a key concept. Raise your hand if you've seen all the Sharknado movies. See, I'm a slacker. I've only watched one, the original one. I feel horrible about that. This is good. Oh, this is funny, actually. Some of these are kind of... You guys, I gotta my hat's off to you. This is pretty funny, some of them. All right. This is good. All right, so don't forget to hit the send key. So don't write a sonnet. You know, you don't need all 16 for this. We're just kind of testing it out. But we're going to do a scientific question like this in just a second, and it's going to be related to the Logan's Run. So it's going to be good. You know what I forgot to do, Katie? I forgot to get somebody to videotape it. Logan's Run. We may have to do an instant replay on Thursday. Okay. You know, just trust but verify. All right, 1 minute. No, 30 seconds. $15 seconds. Don't forget to hit the send key. And granted, you know, this is just practicing today, so It's not part of your semester grade, but eventually, we're going to want to be able to do this on exams, type in codes like this. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, let's swap over to, all right, let's just go down to the middle of the pile here. Check in. See, here's E, Sharknadoes. ELD, Sharknadoes, Mooch, French fries. I hope not. GBD, always consume French fries. Very good. Do you notice anything about this image? Notice anything about the image? Fries is spelled wrong. These guys, this is a famous place up in Burlington, Vermont, where I used to teach at University of Vermont. Al's French fries. I don't know. They left it that way, though. HLN. Let's see. Never mooch my BFF Justin Bieber. Ooh. JPG. FNBA. Walk in always whenever my BFF Justin Bieber consumes Cheetos. All right, good. So anyways, the thing about this is, and it's actually good to start the semester with a goofy one because there's a zillion answers. Look at all these answers that, every answer, or a lot of them, there's just one person that typed that. Matter of fact, I don't know if there's a single one where more than one person sent. No, here's one. 2 people typed in GKD. What is that? Always purchase French fries. Okay, so that's a popular, but only 2. See, so here's the point. When we're asking a scientific question, you're going to be basically writing a sentence. And every one of you, it's possible, can write a true sentence about whatever I ask. And all of them can be slightly different. So this one, if you think about it, a multiple choice question is like the instructor's in total control. I write the question, I write the options, and the only thing you have to do is figure out the right answer and then click it. But this, you write the correct answer, and then I figure out if you're savvy and stuff. Now, this is a goofy example. We're going to do let me switch back to the laptop now. We're going to do a scientific one. All right, now this one's serious, and it's about the skateboarder. And let me start the question. Okay, so hit your refresh key just for safety. Here's the code table. So you have A through Z on this one. Describe the motion of the skateboarder. Describe the motion of Logan's run. All right, when I typed this Logan, I didn't know it was going to be you. Okay, so there's an example, MCQ. And hey, you guys write the question down and then write down your answer in your notes. Make that part of your notes. And you can see, and we're going to look at some of the answers of this and see if they're righteous or not. Okay, there's the first answer. Good. Hear all that clicking? It's nice. And those of you without a clicker, get a clicker as soon as you can. Get it registered, and that'll be good. Axel, what's going on back there? You clicking? Dude. Napping. It's kind of like me with my pencil up here. Slight disaster. Yeah, I did have a backup, you know. Let's see what you guys are doing. Oh my goodness. Oh my gracious. All right, here's a really long one. Oh my goodness. All right, some of this is interesting. And here's what I do with a question like this on an exam. What I would do is I would take your letters, transform them back into the words, and then grade your sentence. You know, it's incredible how many. This is interesting. Yeah, whoever typed, there's some facetious answer. This is a serious question, you know. And just so you know, I can see what you type, and I know who it is. And type it in something good. I'm glad you're changing it. No, it hasn't changed. Well, you have to do what you think is right. Okay, 30 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, now a popular answer was ACN. Speed is accelerating, and that is incorrect. The speed is not accelerating, the object is accelerating. All right? Now, you're close, you're warm, but you're not on target. Let me see if there's a few others down here. The reason I'm not showing you all of them is because one person put in something stupid. Let me see if there's one that's got more than one student. You know, there's a ACX. Speed is changing. That's good. That's true. That's a true sentence. True description. All right, 2 people voted for that. Let me see if I can. All right, there's that. Let me see if there's another one. See, most of these only one. Most of you put in unique answers. Here's another one. UJ through middle of the aisle. Okay, that's a description. You know, here's one I thought was facetious, but actually it does. Zach, Z-A-C-H. And that might. I'm not going to ask for the show of hands of those whose names are Zach, but it's possible that's somebody's name. But actually, Z-A-C-H. The skateboarder speed is constant. Now that's an attempt putting something together, but it's false. Is a skateboarder speed constant? No, because he starts at 0 up at the top. And he's getting faster by the time he's down here. All right? Because remember, I was holding him back. I was holding Evan by the shoulder, and then I went, start! And I turned him loose, and by the time he passed down here by Evan, he was whipping Khaled. Yeah, if that's what you typed in, yeah. I mean, do we have the word never in here? Yeah, so A-R-H, yeah, that would be righteous. Yeah, so now on this thing here, I'm not going to show, we're not going to do any more of these ones. We have some more clicking. But I want you to remember, on an exam or in class, when we do this, I'll be analyzing it for, I'll pull it apart into separate symbols, then translate each symbol back into a phrase or word, and then put them all together into a sentence, and then grade the sentence. And this is another one where I can give partial credit. But the thing I like about this is you could be creative and write a sentence of your very own that no one else has and get full points for it, right? And sometimes the stuff I've never thought of it, and I think, yeah, that is correct. All right, now here's a picture. Let's keep going with our topic for today. We have a few more minutes. We'll get as far as we can today and then continue on Thursday. Here's a picture of some Army men jumping out the back of a perfectly good airplane. I don't understand why they do that, but that's apparently what they're doing for practice to help our country stay safe. And they're going into free fall. They haven't pulled their chutes. Okay, so high altitude, low opening. So they're going to be in free fall for a few seconds. And Galileo chose free fall as his prototypical acceleration. And it's a good thing he did, because free fall at the surface of the earth has a very simple description. It's very simple. It's the simplest of all accelerations he could have chosen. All right, and that's going to be in chapter 2. So that's where we're heading in the next day or so. So if you want to read ahead into chapter 2, section 2, then you can go ahead and do that. Average and instantaneous velocity. To figure out what Galileo was talking about, we need to talk about average and instantaneous velocity and then acceleration. So let's get down to business here. Now, we just calculated an average speed. Okay, it's based on a finite number of position and time measurements. For instance, our trial with Logan's run. The thing about the average, however, is you don't necessarily know what the individual did at any time between the beginning and the end. Now, this is, I just chose a time 0.74 here, for the endpoint time. But for us, it would be, what was the average? 6.36 seconds? Is that what it was? Okay, so for us, it'd be 6.36. But we don't really know. We've got an average speed for Logan, but like you with the baseball hat on the aisle, white T-shirt. Poke him. Connor, the guy behind you. Okay. Yo. What is your name? Reggie? Reggie, raise your hand. Okay, Reggie, when Logan was passing by Reggie, we don't know what speed. I mean, we know he was at a speed, and it was increasing, but we don't know exactly what it was there. Okay? But we can figure it out if we figure out an evolution equation for the speed. So it could have, as I said, it could have been the same speed all the way, or it could have, the individual could have taken a break like the tortoise and the hare, that famous problem. And in fact, in chapter 1, section 11, there's a discussion of the tortoise and the hare fable. And a little bit more practical example on the Turkey Lake Service Plaza on the Florida Turnpike. So that's in chapter 1-10. So the idea is, if all you know is the average speed, you don't know what the instantaneous speed is at any given instant of time. You know, like the tortoise basically gets up to speed and just sticks to it. He ain't, blazing, but he never stops. That's the whole thing about the tortoise and the hare. Low speed, but he just keeps on going. Hare's got plenty of speed, but he takes naps. That's no good. That's how you lose the race. So let's look at the tortoise and the hare fable. Two dynamical ideas behind it. I mean, you don't think about it that way, but you can if you want. So here's the first dynamical idea. Once the tortoise gets going, his speed at any instant of time, all right, and here's about 30 of them, 30 different instants of time, it's the same as what will eventually be called his average speed. All right, so he starts at 0, then he's halfway to his final speed, and then he attains, in the second of motion, he attains his final speed, and he just keeps it going, right, all the way through to the end. All right, so that's the tortoise. And so the instantaneous time is the same as the average time for the tortoise, except for this one blip of time right here when he's getting started. But after that, his average time and his average speed and his instantaneous speed are pretty darn close. Now the hare, he's all over the place. Changes several times, and here he's blazing. He's doing a good job. But he slows down, and he speeds up again, and he slows down, and he stops, takes a nap, dreamland, and the hare wins the race. All right, so that's the famous tortoise and the hare. Now, you could figure out an average speed for the hare, for the hare, but the hare, you don't know from the average speed. And guess what? The average speed of the hare is less than the average speed of the tortoise. And why do I know that? Because he didn't get to the finish line ahead of the tortoise. To get to the finish line, you have to have a higher average speed, among other things. And so he didn't get to the finish line till the next day. So his average speed was, pathetic. But yet his instantaneous speed, all those big blips, those big bars there, vertical bars, he had plenty of instantaneous speed. He just didn't hold it for more than an instant of time, for more than 1 second. All right, so in terms of the instantaneous speed, now the way that we would represent that is V of t. V is a function of time, V of t, V of time, velocity or speed is a function of time. And it's constant for the tortoise, pretty close to constant. A little bit of change at the very beginning, but mostly it's nice and smooth, nothing but net. But for the hare, V of t is all over the place. And the average speed for the hare, which is different from V of t, the average speed for the hare is smaller than the average speed for the tortoise. So now you can read more about that in chapter 11 or chapter 1, section 11. When you get your textbook ready. Now, there's something highly useful about this graph. Now, this is what we call a velocity graph. It graphs the velocity of the object on the vertical scale, in this case, feet per minute. Now, normally we're going to do meters per second, but this one's feet per minute. Okay? And, you can see the tortoise. He's just kind of poking along there at 100 feet per minute. He's just kind of moseying. But he stays with it. And the nice thing about this is it's nearly rectangular. All right? Now, we're going to make, in the next minute here, an abstraction of the tortoise's constant velocity graph. All right, so here we go. Let's make an abstract graph of constant velocity over time. Okay, so this is kind of an abstract of Mr. Tortoise. So let's just make it easy. Constant speed forward 1 meter per second. So on the vertical scale, I've got +1 above, I've got -1 below. Now that means, so positive means rightward and negative would mean leftward. So let's just say that the tortoise in this abstract graph is moving to the right, nice, easy, 1 meter per second. All right? And let's say that the horizontal axis represents time. So we start at 0.0, and let's just say that we're following the tortoise for 2.5 seconds. All right? Now, this is just like the graph in the textbook. All right? The graph of the tortoise and the hare. And this is the tortoise's graph. This is kind of an idealized version of the tortoise's graph. All right? Starts at a low speed and just keeps on and going. Now, that's about 2 miles an hour, 2.2 miles per hour, something like that. All right? So it's kind of poking along. And so what you would say, I mean, your description, I mean, if I ask you again to describe this, the dynamical state here, you would say that the object is moving at a constant velocity, 1 meter per second, and it's rightward for 2.5 seconds. So we call this a velocity graph because we can distinguish rightward from leftward motion. Rightward motion means the graph is up above. Now, we'll do some negative velocity, some leftward stuff or downward stuff, probably on Thursday. The graph is the horizontal dashed line. And it's similar to the tortoise's graph, and it encodes all instants of time visually. So this is something that we couldn't really say for the tortoise. We had a finite number of measurements for him, but this is every instant continuously on this graph. So it's kind of an idealization. Now what we're going to do, first thing on Thursday, we're going to talk about distance polygons based on this as our first polygon. And you'll see on Thursday when we return. Your homework tonight is simply this. Get your textbook squared away, all right, if you can, and I'll see you on Thursday. You're dismissed.